In these slides, we talk about chemical reactions. And so chemical reactions are summarized as chemical equations. And what they do is put the reactants on the left here, and then separated by arrow is the products on the other side of the arrow. So the reactants make the products. You can think of an arrow as kind of like an equal sign. And so here is an example. In fact, this is the one for elephant toothpaste. Right here, the purple, you have hydrogen peroxide as the reactant. And this breaks down into water and oxygen. Those are the products that are in red or maroon or whatever color that is. And so the law of conservation of matter states that matter cannot be created nor destroyed. And so when you have your chemical equation, you need to make sure what you're putting in is what you're getting out. And so if you pay real close attention here, you notice that 2 hydrogens are going in, but only 2 are coming out, which is fine. That's perfect. This oxygen, you're putting 2 in, but you have 3 coming out. So you're actually creating matter. This does not follow the law of conservation of matter. And so you need to fix that. And so I would do an element inventory so you can quickly identify what is happening here. So if you notice here, 2, getting 2 out, that's fine. 2 oxygens in, 3 out, not fine. You need to balance. And so if you put a 2 here, you can only put the numbers in front of the chemicals. You cannot change the subscripts because then you'd be changing the identity of the chemical. So you can only put numbers in front, which are called coefficients. And so if you put a coefficient 2 in front of the water, that would change the number of oxygens coming out, correct? So you have now 2 times the amount of water. And so now you have 2 times the amount of oxygen from the water, but you also have 2 here. So that's 2 plus 2 is 4. And then you have 2 times the hydrogen here, which is 4. And so if you look here, still not balanced. But if you think you can put a coefficient here, then you're on your way to fixing it. So if you put a 2 here and have 2 times as much peroxide going in, that would make 2 times as many hydrogen and 2 times as many oxygen. And so then if you look, see if it's balanced, 4 hydrogen coming in, 4 coming out, 4 oxygens coming in, 4 coming out. Balanced obeys the law of conservation of matter. So again, these numbers that I put here are called coefficients. Okay, so we're going to talk about types of reactions. There's combination, there's decomposition, there's single replacement, double replacement, and finally, we're going to talk about combustion. So let's start with combination, and then we'll move on to the rest. So combination reaction happens when 2 or more reactants combine to make a single product. And so the example of a chemical equation that does this is sodium and chlorine. They will combine and make your table salt, sodium chloride. So you have 2 reactants and they make a single product. Decomposition reaction happens when a reactant breaks down into 2 or more products. And so, in fact, the elephant toothpaste is an example of a decomposition reaction. You start off with 1 reactant, and you end up with 1 or more product, or 2 or more products. So water and oxygen right here. Okay, single replacement reaction happens when a compound and an element takes the place of another element in a compound. And so you have element A, and then you have a compound that has B and C. And this A is going to take the place of B in the product. And so you end up with B plus A, AC. And a real example of this would be iron plus copper 2 sulfate makes copper and iron 2 sulfate. So the iron kicked off the copper here. And so you end up with iron 2 sulfate. Okay, double replacement reaction happens when cations and anions switch between the 2 reactants during a reaction. And so here you have compound AB and CD mix. And so A and C will switch. And then you'll get AD and BC. And here is a real example of that. You have iron 2 hydroxide, copper 2 sulfate. So the iron and copper are going to switch. And so you end up with copper 2 hydroxide and iron 2 sulfate. Lastly, combustion reaction. We talked about this a lot. And it's when you mix any kind of hydrocarbon, in this case it's fossilized hydrocarbon, methane, It combines with oxygen in the presence of heat, and it produces water, carbon dioxide, and releases energy.